Hey, how's it going? Uh, I felt like this was a much better title for my talk than what was in the schedule. Like integrating Google Maps with DeckGL just seemed a little bit dry. So I wanted to spruce it up a little bit. More than anything, I think that this coming here to give this talk today is like just an excuse for me to stand up here and thank a whole bunch of people who have done a ton of work to make all of the great features of DeckGL available with the Google Base Map. This is actually the first talk that I've given since before the pandemic live. So I'm really excited to be doing it here with this group of people. And I got in last night about 10 o'clock. I'm on about 2 hours of sleep because of jet lag. So we'll see how this goes. All right, cool. So it all started in 2019 with an RFC and a dream. In April of 2019, Xiaoji published the RFC for the Google Maps overlay that was based on a bunch of conversations that had happened up until that point between the DeckGL steering committee and our team, in particular Don McCurdy, who was on the Earth team at the time, I believe, was a major contributor to this. This is also about the same time that our engineering lead, Travis McPhail, says to me, have you seen this DeckGL framework, data visualization framework? And I hadn't. I had been with Google for less than a year at that point, and I believe my exact reaction was like this. I was like, what is that? and when can I have it? And it actually just so happened that very shortly after this RFC was published, what was it? It was like 7.6 beta 3 of DeckGL. The beta support for the Google Maps overlay was released. But there were issues, right, that were initially blocking the ability for DeckGL to work with the Google Base Map at all. Primarily from the start around issues of camera synchronization. So at this point in time, the Google Base Map was only offered as a raster tile map, right? So we were only doing raster tiles, and so there was DeckGL had been made to work with React and WebGL, right? And so there was no good way that was readily apparent at the time to keep DeckGL's camera in sync with the base map, particularly around issues like zoom levels. So bear with me on this jet lag here for a second. So the raster base map only supported integer zoom levels, right? Whole numbers. So, and when you went between zoom levels, we would do some interstitial animation to make the movement between those zoom levels smooth. But there was really no way for DeckGL to either control that zoom animation at a level, or control that zoom animation in a way that DeckGL could understand, because we didn't support fractional zoom levels, right? And then also the zoom events that were being fired by the base map to describe the movement between those zoom levels didn't work in a way that DeckGL could reason about. Did I get that reasonably right, Xiaoji? Thank you. So that was a big problem, but turns out that there was a pretty good solution. We actually had this API that has been around for almost as long as the Maps JavaScript API that's called Overlay View. And Overlay View essentially puts a transparent layer over the top of the base map where you can inject various things, right? Like people have done all kinds of different stuff with Overlay View. And the Overlay View actually exposes a projection matrix, or not a projection matrix, but it it exposes a projection that Xiaoji was very was very nicely able to reverse engineer in order to allow DeckGL to stay in sync with the raster base map. Also, a really cool, I felt like a really cool feature of this, right, was that WebGL or DeckGL injects its WebGL context into the overlay view so that you get all of the WebGL accelerated niceties of DeckGL, but completely synced on top of the base map. So, like I said, and I think it was like 7.6, the beta support was released, and our team very quickly got on board to try to spread the word that DeckGL, about how great DeckGL was, and that it now worked with the Google Map. And it looked like this. So the nice thing about this, right, you create an instance of the Google base map, you handle your DeckGL layers the way that you would in any other DeckGL app, and then give that layer to the Google Maps overlay submodule, and then apply the overlay to the map, and everything is just taken care of for you. This was something that was also really appealing to me when I first saw DeckGL, right? It's so easy to actually build with. And so this got us to a pretty good point, right? We had some really cool looking data visualizations, and we were able to start talking about DeckGL, but again, only on top of our raster tile map. So you can see that in these screenshots, everything is just a 2D top-down view, right? So, but the big deal was that this opened the door not only for showing how cool DeckGL was and how powerful it was, right? It wasn't just that it gave Google Maps like a data visualization story that it really hadn't had before. It really opened the door to showing a whole new generation of visualization capabilities that were possible on top of the Google base map. Not to mention that also it added support for multiple magnitudes more data points than were previously supported. I mean, I think most people who have used Google Maps for the web before, you know the marker, right? The basic red pin. Well, the Maps JavaScript API on its own only performantly supports about 300 of those, right? When DeckGL came into play, I personally put 300,000 data points on the map, and it performed great. I have heard somebody has gone as high as 1 million, but I haven't actually seen that one run yet. That's what they say. Yeah.
Sorry, just anecdote. I've run. San Francisco has an official LiDAR scan. That's point cloud. That was before we had a tile 3D layer or tile layer, and I've loaded at most 10 million points into the browser. That's how much the memory would hold. It didn't crash. It's about 1 frame per second.
So just a little janky, just a little. So yeah, but even though we basically still only had the 2D top-down base map, right? It was kind of cool because we would still get like parallax, like some amount of parallax effect when panning happened, for example. So started to really show what was going to be possible, right? But there were still issues. The first being, no vector map, so there was kind of a fundamental incompatibility with DeckGL as a WebGL library. Didn't support tilt and rotation, meant that we couldn't take advantage of some of like a lot of the really beautiful 3D aspects of DeckGL. Like I said, no WebGL, and then of course no direct React support. There's no official React wrapper for the Google base map at this time, and so this was a lot for us to try to figure out, how do we move forward? How do we support DeckGL and kind of get full integration with the Maps JavaScript API? And there was a lot of other questions that at play, like what is data visualization at scale something that Google Maps users wanted, right? Is it something that developers were going to be able to do interesting things with? So to get the answer to that, we went out and we talked to developers. In 2019, I went to 25 cities in 20 countries and talked about DeckGL. And I'll tell you, I have never given a technical talk about anything that has gotten as many oohs and ahs from developers as DeckGL. The last time I was in the UK, I was giving a talk about it, and they did it twice for the same exact demo, which was pretty awesome. So the point is just that by going out and talking to developers and showing DeckGL, we were really able to show that there was real demand for supporting this type of framework and the types of features that DeckGL brought to the table. And at the end of the day, also really important because it allowed us to push forward on a whole set of features that were going to be needed to get full integration of DeckGL with Google's base map. So that brings us to Google I/O in 2021, where we announced the vector map in beta. So for actually many years, right, Google had a vector base map, but it wasn't exposed for JavaScript developers on the web. It was only on maps.google.com, right? So thanks to DeckGL and the enthusiasm that we were able to drive with that, we were able to actually push forward on releasing the vector base map to developers. So this brought a whole slew of things to the table, including fractional zoom, which was kind of one of the original issues, right? Tilt and rotation for supporting those 3D views. Also, for the very first time, it exposed our what we call our 3D oblique building models, which doesn't show up very good on the screen here, but it's the gray buildings. So that had never been available in developer apps before. And also we released WebGL overlay view. So has anybody heard of WebGL overlay view? I know that you have, Felix. I don't think you have too much. So as part of the beta release of the vector base map, we also released in beta an API that exposed lifecycle hooks directly into the WebGL rendering context of the vector base map. So this meant, for the first time, not only did you get the vector map, you got a way to literally draw directly on it as part of the exact same rendering context. So we provide various lifecycle hooks so that you can tap into the onDraw method. This is really cool. Also a little bit complicated and dangerous in a number of ways, because anyone who's worked with WebGL before knows that like a shared context like this can lead to many issues. But this is also why frameworks like DeckGL are really important to our team, right? Because it allows developers to get a lot of these added benefits without having to navigate the complexities of WebGL themselves directly, right? Also, WebGL Overlay View provided a set methods for coordinate transformations from world view to screen space to like the screen space, and then also because you're rendering directly within the same WebGL context on the base map, you get depth and occlusion around things like those oblique building models. And so that's what gets us to kind of full or mostly full DeckGL support for the Google base map. Really quick, I want to thank Felix Palmer in particular, who did a ton of work on making this happen, because this was not a small thing to because DeckGL at the WebGL level is so complex. So we announced this at Cloud Next at the end of last year in October, and again, this brought full depth and this brought all the 3D visualizations of DeckGL into play on the Google map with depth and occlusion. Also, a really nice feature is that there's automatic detection of the raster and the vector base map. So you can implement DeckGL on the Google map once, and if it's a vector map where it can actually draw to the context, it will do that. Or if you're falling back to the old raster tile map, it will automatically fall back to the old way of using overlay view, which is a super nice feature. So again, just like a million thanks to the Cardo team and to the DeckGL steering committee for making this happen. It was a really big deal. It was a really big deal for me personally, but it was a really big deal for our team as well to see that happen. And so for the first time, we get kind of real full DeckGL support. These are pretty simple examples actually, but it's just amazing the difference that it makes when you have that WebGL overlay view integration at play. I also just want to take a second to call out the really awesome story map demo that the Cardo team built as part of the launch of this feature. You should totally go to next.cardo.com and check it out. It's a really nice showcase of some of the things that can be done with the map. And another really cool thing is that it still just looks like this, right? So full support or nearly full support for all of the features of DeckGL, and it still is just this simple to use it with the Google base map. The only difference is that now when you load the map as part of the options, you have to use what we call a map ID, which is what you need to enable the vector base map as well as tilt and rotation. But beyond that, it's exactly the same. And we actually, so for both WebGL overlay view and the vector map, we made those generally available. So those are like full release as of May of this year. So everything is production ready and is fully supported by Google. And it all started with an RFC and a dream. It's been a really, it's been a really productive couple of years, pandemic withstanding, I suppose. And we've pushed forward a lot of really great features, not just in terms of making DeckGL possible, but again, like in terms of the actual Google base map as well, right? I mean, it's a perfect example of how supporting open source can have many different like multiplier effects, not just for the open source community, but for for developer tools like Maps platform. And this is the result of that. So now the Google Maps submodule is at almost 80, I took this like Thursday, I think, 81,000 weekly downloads. That's only about 2,000 short of DeckGL core. And that's going from 0 and only 3 years ago. So it's really quite an amazing increase in usage over a pretty short amount of time. So real quick, I'll just also talk about kind of what we're thinking about next. But before I get into that, I just want to stop one more time to really thank the DeckGL Steering Committee, Cardo, the team at Booby Labs has done a lot of work with us on this as well. And just to say that, Google Maps platform is a better and more useful developer platform because of the DeckGL community. And I think that that's a pretty big deal. Because not only has it pushed forward DeckGL, right? It's pushed forward the Google base map as well, which is definitely no small feat. And a lot of those features, right, are not just about WebGL, they're not just about DeckGL, right? They're features that give developers greater control and customization of the map than has ever been available up until now. So again, I wanted to just say thank you on behalf of our team. So what's next? Like I said, we just GA'd kind of the new features in May. So nothing is set in stone yet, but we're starting to talk about a whole variety of different things that we could explore next. The first being just deeper and easier integration of DeckGL with the Google base map. As you might imagine, Google has lots of geospatial data, imagery, et cetera, right? POI data, also place data. So, how can we make that more readily available to DeckGL, and how can we make it easier for people who use Google Maps platform to adopt DeckGL? Also starting to investigate different options for React support. Xiaoji and Felix, hopefully we can talk about that while we're here in Madrid. And of course, continuing to work with the DeckGL Steering Committee all along the way. I actually didn't originally have that on there twice, but it's important to reiterate. And that's it. Thank you.
Thank you, Alex. Well, I mean, it's been a pleasure to work also with the Google Maps team on this, to get this ready. For us, I think it's a very important milestone. Obviously, Google Maps is a huge developers platform. It has like millions of users. So I mean, having this completes a lot the picture. So thank you for that to the Google team too. Now, right. And DeckGL, so I mean, this is great, it speaks a lot towards, the open source, and the open core movements, that we can collaborate like this. Now, later today in the afternoon, we've got a session. We're going to be talking about base maps. I'm going to go very straight here, Alex, and put you on the spot. But, one of the issues we're having now is DeckGL now has support for Google Maps. Hopefully very soon it has for MapLibre through Map.gl. There's a number now of base maps provided that we're looking at supporting. And I think that is a very, very important part of the DeckGL product as a product. But yeah, it also means that, it's much more work for maintainers and so on. So one of the things I'm going to be discussing is will be Google maintaining, will be able to commit resources to maintain the Google Maps module on DeckGL? Is there plans to put resources in place so that And one of the things that we find is that if Google Maps change some things on the WebGL overlay, that might break the integration with DeckGL. So it's always a little bit tricky, right? So so one of the things I'm going to be, and we don't need to answer now, but I'm going to be asking is like, what is the relation of DeckGL with the base maps providers, and how we can make sure that that collaboration is effective, and that we distribute the load between all of us, right? So that's one of the things, just so that we're going to be talking later today. So. With that being said, is there any questions for Alex on the Google Maps?
Thank you, Alex. It looks really cool that one can combine like the very powerful base maps from Google and DeckGL. Now, I have a question about licensing. I remember last time I looked into Google Maps API, there was a restriction that you could only use it if like you cannot just use like the tiles, the base maps. You have to use the Google Maps API, right? Correct. Like, but this approach, I guess it does comply with this, right? Because we have to use this WebGL overlay, which is part of the Google Maps API, right? But you cannot do like vice versa, use DeckGL or React Map.gl and integrate base maps from Google into your app, right?
Yeah, I mean, there's a limitation in the terms for using Google Maps where you can't use the tiles with like for example with a different base map provider. But does that answer your question?
But this approach.
Yeah. Oh yeah. This approach totally complies. Correct. Yep. Correct.
And if I add to that, I mean, the reality these days is that if you're going to use any vector base map, you almost going to need to use the rendering engine of that vector base map provider in a way. So the same way that Mapbox or Mapbox.gl or MapLibre are like the best way to render kind of like MBT base map layers. Yeah, you can do that on DeckGL, but I mean, maybe that's an interesting topic for discussion. I don't think DeckGLs, or at least on my perspective, I don't think DeckGL should try to be a base map renderer. And what I mean with that is like, for example, the Google Maps tiles on vector is not even an open format. So there's no way that we can know how it's rendered and all these things. And neither MBT layers are actually right now an open format. So, and they are like settable. And Mapbox probably has now like a different versions of MBT for their 3D stuff and so on. So, I mean, from my point of view, I think that is the reason why we have to make sure that DeckGL works well, overlaying or interleaving with the base map providers, because if we go the route of trying to DeckGL be the one that does the base map rendering too, it will be an equivalent amount of resources and probably will never have the best technology and the best data.